Hi, Alicia.
Hey, hello. Good evening.
Hi, Cynthia.
Hi, good evening, everyone.
Hi. Hello, everyone.
Hi everyone. Hi Alicia. Hi Ale. Hi
Hi.
Christian.
Hi. Nice to meet you, Alicia.
Nice to meet you.
Oh, right. I haven't introduced you guys. This is Alejandra. Alicia.
Hi. So shall we wait for like a couple more minutes before the introduction?
Yeah, sounds good.
Okay, great.
Ale, how many people are we expecting today? The full cohort, right?
Yes, but I think we will have at the beginning probably 12 of or 15, and then the other ones will join.
Okay. We'll wait maybe 2 more minutes. Let us know, Ale, when you think we should start.
Karin, I think we can start.
Okay. Thank you, Ale. So welcome everyone. I see all these familiar names. I want to congratulate you guys of reaching the end of the program. You know, you guys have already done your capstone exam, and now is really the final showing off your accomplishments during the last year and a half. Um, so today, I know that you have already presented, your results to yourself last term. So tonight, Alicia, I will introduce her soon. Alicia will be giving you reflections and comments on your presentation and your project, uh, independent of the feedback you've given before. So we'll take it as like a final presentation, take it as a standalone presentation, and give you feedback. What we think future directions could be, what could have gone better, and also we would like to hear your questions as well if you have them. So I think the format is familiar. The first group will present, then Alicia will give her comments and questions, and then the second group will present, and then and Alicia will again give the comments and questions. So let me introduce her. So Alicia here, she's on camera, and I hope all of you will show your face at some point on camera. So Alicia Yi Sun is a senior PhD student working in data to AI lab at MIT Laboratory for Information and Decision Systems. Her research interests are designing machine learning algorithms that are both robust and reliable, and also aligned with societal values. Okay, so without further ado, I think I will let Alicia say hi, and then the first group can present.
Great. So thanks for the introduction, Karen. So I'm so excited about like hearing about like the final presentation you put together for tonight. So I guess maybe we can just like let the first team to start with their presentation. I think the first team we have is Data Care, and Cynthia and Christian will be presenting. So you guys can take over now.
Yeah, that's right. Right. I am going to share my screen. Please let me know when you can see it. Yeah, can you see?
Yes.
Yes.
Yeah, awesome. Right. Good evening, everybody. We are happy that tonight we can share with you the two projects that as Data Care we work together with CARE in the last year. Actually, more than 1 year, we have been working on these projects since the last semester of 2020. Before continuing, I would like to present to you my team. We are 6 engineers: Sebastián, Christian, Manuel, Aaron, Bruno, and me, Cynthia. Tonight, Christian will join us in this presentation. Well, CARE. CARE is an NGO with a presence in more than 90 countries around the world. Here, CARE has a subsidiary in Peru. Here in Peru, CARE is in charge of many social programs oriented to health, mental health, education, and so on. One program is Hot Meals, which is soup kitchens. Among the beneficiaries of CARE, we can find people from different nationalities, people from Peru, Venezuela, or Ecuador. With all of this, CARE seeks to help achieve the Sustainable Development Goals in the United Nations 2030 agenda, goals such as no poverty, zero hunger, and so on. Well, now about CARE. First, we have to know how a beneficiary is registered in CARE. CARE asks for a document in order to register a beneficiary, and one person can have up to 6 different documents. For instance, I can go to CARE with my national ID. With my national ID, I can have the number 123. In the following month, I can go to CARE with my passport, and in my passport, CARE will find another number, 456. And because my national ID and my passport is, they have different numbers, I can be mapped as 2 different persons in CARE. So in this way, CARE lost traceability of the beneficiary, and this is an issue in the NGO. Well, with all of this that I told you so far, we were thinking as Data Care what we can do in order to help with analytical projects to the NGO. In this way, we decided to create 2 big projects. First, a project called Dashboard, and second, a project called Unique Identifier. Here in this slide, I am going to tell you a summary of both projects. And later in the following slides, we are going to tell you further details about them. First, the dashboard. This project is called the dashboard, and here we wanted to give her graphically, we wanted to show her in the OKRs in order to help them to take decisions. And this project was exclusively oriented to Hot Meals, the soup kitchen program that I told you before. And this was because CARE wanted to focus specifically in this program. So we developed the dashboard just for hot meals. Here, one deliverable was the dashboard, but we also have 2 additional deliverables. One was the data dictionary and also a satisfaction report. For this, we use different softwares, Excel, Power BI, and RStudio. And in the following slides, we are going to show you more detail about this. And just one more thing, in order to elaborate a dashboard, we use 3 different databases: personal information, pre-service survey, and post-service survey. Well,
¿Puedes poner tu video para...
Aaron, I think your microphone is on. But, continuing, the second project was the unique identifier. The unique identifier, here we wanted to solve a problem that we told you about. This problem that a person can go to CARE presenting different documents, and the person can be mapped as 2 or 3 or more different people. So in order to solve that, we wanted to create a unique identifier, and for this we elaborated a unique code, and then we elaborated an app so the coordinators of CARE can use it in the day-to-day activities. So for this, we use different software as well. Well, in the following slide, we are going to show you more details about these 2 projects. The first project, the dashboard. Here, we wanted to elaborate a Power BI view about hot meals, but before we started to elaborating this Power BI, we realized that the NGO CARE doesn't have data list or data dictionary with all the details about the fields in the databases and with the description. So proactively, we elaborate this and provide this to CARE, and they say that this will be very useful in the future projects. Well, I was almost forgetting all of these deliverables, and both projects, we already showed them to CARE, and CARE is very happy with the results. Well, now continuing, we elaborate a data dictionary before elaborate the dashboard itself. Now I am going to show you the dashboard itself that we elaborate exclusively for hot meals. This dashboard has 4 different views. The first one is oriented to the pre-survey analysis. And here we can see that there were 700 families that applied to hot meals. And we have openings by results and sex. In opening by results, we can see that there are families that as a result, they get a result that's not qualified or qualified, or they are waiting. And if they are waiting, later they can be qualified as good. They receive the program or they not. The second view is about the beneficiary analysis, and here we have openings by sex and age range. The third view is about the servings, and here we have openings as well as sex, age of range, and also nationality. Here we can see that this program was in the majority was oriented to people from Venezuela, also few people from Peru, a couple of people from Ecuador. The last view is about the post-survey analysis. And here we elaborated 2 word clouds. And these questions was obtained from the post-survey analysis. And those 2 questions was also deliverable by CARE. And they say that they were very interested in the results of those questions. Here, the first question in the left part is, what is the greatest need or difficulty you have right now? People in the majority says that they have 3 main worries: rent, work, and payment. In the right hand, we can see that another question about what have you value the most about the help you receive. We can see that the people are very grateful with the program, with care. So they say that the three words that the most appear were health, food, and everything. They just say that they value everything about the program. And this 4 views was related to the dashboard. Finally, the third deliverable related to the dashboard was the satisfaction report. Here we wanted to do a zoom about the satisfaction survey that they have. We elaborated openings by food, staff, and the overall program. And we did it in our studio. And here we can see that people are very satisfied with the program. And also, when we elaborate this, we realize that it's not anonymous. You have to give your name in order to do the survey. So Data Care here recommend to Care that they can evaluate to do the surveys in an anonymous way. So people are not afraid to say that they are very satisfied if they are. Well, and until now, this was all about the dashboard. Now we are going to begin with a unique identifier project. Here, the first step was to create a unique code. And for this, we in Data Care review all the documents that people can present to Care. And when we review all the documents, we realize that there is always 3 fields that appears: names, last name, and date of birth. So based on these fields, we create a unique code using the names, last name, and date of birth. So here we have an example: 2 different people with 2 different names, 2 different last names, 2 different dates of birth. And as a consequence, they have 2 different unique codes. With this, we said, okay, we have a unique code per beneficiary. What else we can do? In this way, we created an app that can take a picture of the documents and also a picture of the person that is holding the documents. This app can check if the person that is holding the document is actually the person in the document. And if he is or she is, the app will give you the name, last names, and date of birth that are in the document, and also will provide you with a code, with a unique code. We realized all of this, and here we say, okay, this can help Care in the activities, but this has constraints. What constraints? First, Data Care has no cloud support, cloud technology support, so we couldn't create this for all the beneficiaries of Care. We can use it because Care says that we can share the data in the clouds. So here we have a data restriction, a data policy of restriction here. And besides, Care also doesn't have cloud technology support. So it was very difficult to implement this. But we actually wanted to show this app of a proof of concept to Care in order that in the future Care acquire cloud technology, and also if Care is more flexible with the data, maybe they can implement this in another project in the future. But in order to have a short-term impact, we develop a macro that Care can use it in the day-to-day activity. But before to show you the macro, we wanted to tell you more details about what is the technical detail behind this app that I just present. And for this part, Christian will help us, giving us more detail. Christian, let's go with you.
Okay. Now I'm going to explain the system of creating the unique identifier using images. First, we have to talk about the database that we use. As Cynthia said, as a result of data privacy regulation, we have not been able to access to Venezuelan documents, but we use images from the internet. In total, we have downloaded 300 images of people, Venezuelan people. And after this, each member of the group has reviewed a subset of images. And each member of the group labels the entities of the interest. As a result, as you see in the picture, we have identified the type of the document, the name, the surname, the date of birth, and also the presence of a face. It's important to recognize the presence of a face because we need to clean our database, and we only use images with a face. Now with this database, we can evaluate if our system, if our algorithms works properly. Okay, thank you. I will explain the OCR-based model. In order to obtain the text from an image, we use an Azure service. This service analyzes documents and returns the text information. We want to evaluate our system with 3 metrics. The first metric is string matching. This metric evaluates if 2 texts have 100% of match, which means that all the characters of the words are the same. And also the second metric is the fuzzy-wuzzy matching. This is a similarity function that measures the distance between 2 texts. And finally, we use the Euclidean distance because we want to understand the position and also the relative position of the text in an image based on the spatial information of the Azure service. Right. Next, thank you. Now we want to explain all the process of OCR and NLP with 6 main steps. First, we know the input is an image of a document, and this image can be rotated at any angle. It doesn't matter. And also, this image goes to the OCR model, and we get the information. We get the orientation of the image, the text, and also the position of each text in the image. With this information, with this inclination and position of the text, we can apply a transformation in the step number 3. It's important to apply this transformation because we want to align the image in order to get a digital representation, because we want to use this image later on. In the step number 4, we made a similarity search to obtain the entity that is more similar to the word that we want to find. For example, the last name can, in the step number 4, the last name can be appear in different ways. In Spanish, is apellidos, and it can be appear in different ways. With maybe one character could be wrong, or maybe the image could be can have maybe the image have a damage, and that's why we use a similarity function, because we want to obtain the word with high similarity. In the step number 5, as a result of we have the image aligned, we can find the entity, the information of the last name, because the image is normalized and the information of the last name will be always on the left of the word last name, right? And it's easily to find this word because we know how the official document of a passport looks like. Well, finally, we do this process to all the entities. In the image is an example of a last name, but also we use this process to the first name and to the date of birth. Next, please. Okay, now I will talk about the face recognition process. In this case, we use the two images, the document of the person, that could be the ID card and also the passport, and we use the face of the image. It's important to understand in this step that the face of the document is a static face because we only have one picture, but the face of the person could be variable along time. And it's important to remember that because we define all of our process with this information. In the second step, we use a deep learning model based on one-shot learning. Because we only have one picture of a person, the document, in our database. And the idea is that our network can recognize a person with only one picture. That's why we use a model based on one-shot learning. And our neural network learns the representation of a face and also learns a similarity function. And finally, we get the faces in the last step. We get the faces in an n-dimensional space, where the most similar faces are close, as you see in the picture, and the different people are farther away. And we use this information of the feature vector that our model create, and we can find the photo with high similarity. And if the similarity is above of 70% of similarity, we say that the person exists in our database. Okay, now I will talk about the recommendations. In order to improve our results, we recommend that we need to avoid bad lighting in images and also bad resolution. And we encourage to use images with good lighting, good resolution, and also the face should be aligned, because in the official documents like a passport, your face is aligned in the photo. Next, please. Okay, finally, putting all the processes together, the OCR, NLP, and face recognition process, we have a system that can recognize the name, the first name, the last name, and also the date of birth. And also our system can verify if the face of the person exists in our database. Our accuracy is 76%. And we know that we can improve our results because our solution is based on deep learning. And we know that with more data, we can improve our accuracy. And also we can implement our human in the loop process in order to reduce our error with the feedback along the time. Okay, well, that's all our system. Thank you. Let's go, Cynthia.
Yeah, for the last part, and I know that we are getting out of time, so I am going to run this last part. Here, as Kirsten explained, we developed the unique identifier app using cloud technology, but as I mentioned, there were restrictions in the NGO, so we couldn't use this app for all the beneficiaries of care and in the day-to-day activities. And in order to have a short-term impact, we developed a macro that you are seeing in this slide. We developed this with constantly feedback of the NGO. Here, all the fields are optional, except of names, last name, and date of birth. Those fields are mandatory. Currently, CARE is using this macro. We are giving them support in the use. And the idea is that they can use it in 6 different projects and have an impact in more than 80,000 beneficiaries. Now, conclusions, final conclusions, we here have two groups of conclusions. The first group is related to the dashboard. And here first, displaying information graphically helps to show the reality in more interactive way. And the second conclusion is that data care recommend to care to evaluate conducting the satisfaction survey in an anonymous way. So in order to not have biased responses. The last group of conclusions related to the unique identifier are first, a unique way to identify a person is using names, last names, and date of birth. Second is that due to limitations in cloud resources and data confidentiality, the generation of an application that uses image and text recognition to identify each beneficiary was developed only as a proof of concept. And the last one, nevertheless, to have a short-term impact, a macro in Excel was built so that it can be used in CARE's day-to-day activities. And in addition, this macro will be used in order to create a unique code for the beneficiary history. And well, that's all. Thank you so much for your attention.
All right, great. Thanks so much for your presentation. As I think it's like a really interesting and impactful project. So I think since this section will be like more like a self-reflection, maybe we can like just like start to like maybe like reflect a little bit like what do you think that you could actually done better in this project? Like any member from the team, like feel free to answer the question.
Hi, Alicia. Sorry, I didn't hear the last part.
Oh, like I'm just asking like what do you feel that you could have done better like throughout the process, like the project? Yeah.
Yeah. First, maybe talking about the dashboard. Here, we developed this dashboard just for one exclusively program. I think that as a project, we could also apply these graphically OKRs for other programs, but we decided just to do it for hot meals because it was the main concern for the NGO. But maybe for future works, it can also be applied for other social programs. This is the first one. Related to the macro, well, to the unique identifier here, what we could do better. Well, actually, we wanted to use this app in the day-to-day activities of CARE because we think that it has very good results, but we would like to apply maybe just a few beneficiaries, but we could them for the data privacy of CARE, but we would like to do that.
Oh yeah, I definitely think like the performance is quite impressive. Like on that note, like I also wondering like if you guys have like measured on like maybe like different segment of the data, maybe like does it like performs particularly well for like one type of the IDs, or like it performs better for like one like people from like one country, or like better for like female versus male, something like that. Yeah. Because it's like a kind of like an aggregated metrics, and like also like have you guys like also measure like different error metrics, maybe like false positives and false negatives on the data set as well? Because I assume like the accuracy is like how many like how many IDs that are correctly identified that actually appear in the data set or something.
Yeah, we use accuracy as a metric because, well, it's important for the NGO to recognize if the, as you said, if the person exists in our database. Well, it is the main metric because if we made an error of, for example, one character, we cannot recognize the person. For example, if the name is Christian and I recognize Cristiano, for example, our algorithm will fail. That's why we use the accuracy and also the metric string matching, because it measures the 100% of match of the real text, well, the real name, and also the predicted name.
Yeah, like I'm wondering, like, what if, like, if they're like, do you measure maybe like if something is identified as like a duplicate, but like it's actually doesn't appear in the database, versus like the case if like it's not identified as a duplicate, but it's actually it's like there's like a duplicate record in the database.
Yeah, you're right. In our process of registration, we have two options. The first option is to register when the beneficiary go to the NGO in the first time. The idea is in the first time we register all the information, then the name, the first name, the last name, and the date of birth, and also we save the photo of the official document. And after that, our idea is that we can use our system if the beneficiary goes, for example, in the second time, maybe 1 month later, maybe the beneficiary can use another document, or maybe can make a fraud and change his name. I don't know, but there exist many alternatives that the beneficiaries can change all their information, and the NGO should be capable to recognize this problem. And with the photo and with the document, it is a robust model.
Yeah, yeah, like I think my next question is like, have you observed like the model performance is kind of sensitive to different choice of the parameters, like, or like different design choices of the model? Because I remember, like you mentioned, there's like a 70% like threshold, just like to I think it's like on the previous slide or something. So it's
Yeah,
like a threshold using to like distinguish whether these two things are, whether the two image or like two texts are similar or not. Like have you observed, like if you change the threshold a little bit, like the similarity threshold a little bit, does your performance is kind of like highly dependent on this?
Yeah, in this part of the process of face recognition, we made an analysis with our database that consists of 300 images. We analyze all the distance between the official documents and all the faces in our database, because we want to find this properly threshold, right?
Mm-hmm.
Yeah, but this threshold can be variable along the time. As I said, in a real implementation, we can make a human in the loop process, so we can save all the feedback, all the performance of the model in real data, and we can change the threshold with the new information in order to improve our accuracy, maybe, or not be, how to say, not be strictable, not make a hard I don't know. It's more easy to find a similarity function with real data, and we can reduce our error with that.
Yeah, definitely. I think I think this is definitely like kind of like an important thing to like an important design metrics. And like things like I think you guys like did a great job like in kind of tune it with like just like compare it with like all the image in the data set. Yeah. Like another like reflection problem is that like have you guys like encountered some problems that you have you didn't expect before like when doing the project? I know like you mentioned like there's like the security or like the storage issue with the image. Like is there like any other things that come into mind?
That's well, actually there were three problems. The first one was the data confidentiality that you mentioned. The second one was the care where the NGO does not have a cloud technology support. That was the second issue, and the third issue was that the databases that currently are in the NGO is not well organized. So it was very difficult to structure the data in order to create the dashboard or have other kind of outputs. That's why we first decided to create the data dictionary, and later we organize all the data in the databases. And the last part was actually the dashboard, but the main difficult part was to organize all of this data.
Yeah, definitely. I can imagine that would be like kind of like super messy to begin with.
Yeah.
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 Definitely. Yeah.
But actually, it sometimes happens. Also, in work, you can find the part that take you the most time is to organize the data. And once the data is organized, you can do different kind of analysis and go further and predict something.
Yeah, I think it's like definitely like a very interesting problems. I can see like as you guys like maybe get more data, this like tools definitely could be like more powerful. Because I would like I'm just like asking out of curiosity, like is it like very common for people to use like maybe like multiple IDs to kind of benefit from from the system? Yeah.
Well, here in Peru, actually, Peruvians in the majority use just the national ID, but the beneficiaries of PER are people from different nationalities, also foreigners, and people, for example, from Venezuela. It's very common that they document the national ID is the national ID that they have in Venezuela. If they are in Peru, they also can go with a passport, and passport is very, very common between them. The birth certificate is very common for people underage, under 18 years old. So you can find this for the children. And these last three documents are common for people that are foreigners but want to have a national ID. It's like when a foreigner in the US transmit the alien card, something like that. So here in Peru, you can get these three different documents, a temporary permit of permanence. This is very useful for foreigners because with this document, people can get jobs, official jobs here in Peru. So this document is very common. And the immigration card, it's also another document that people get here in Peru. With the refugee applicant card is less common, but also foreigners can have one.
Yeah, that's like a lot of IDs. Like, so people are not kind of like intentionally trying to exploit the system, just like they just have like multiple copies of the, okay. Yeah, that makes a lot of sense.
Yeah. That happens. Here says that sometimes people go, well, the first time go with the passport and then they go with a national ID from Venezuela, even though they are here in Peru, they go with a national ID. So they sometimes are registered as two different persons and they can get a beneficiary twice, because CARE has a policy that in 3 months you can just get one you can have just one beneficiary. So if you go with two different documents as two different persons, maybe you can get the benefit not only once but twice or 3 times.
Yeah, definitely. Yeah, I can imagine that, because I also like carry like maybe 3 or 4 IDs with me every day. It's like you use it for like different reasons. Yeah, I think maybe we have to move to the next group, but like thank you so much. I think it was like a great presentation.
Thank you to you.
Thank you so much.
Thanks.
Bye.
So I think the next team we have is root data, and I think Andy and Gonzalo will be presenting it.
Yeah, I think Andy is going to share his screen, so we can start. Yeah.
Yeah, like you can start. Yeah, you can start whenever
okay.
you're ready. Yeah.
Thank you. I'm gonna put my camera also. Well, yeah. Good night to everyone. Good evening, wherever you are. We are the group Root Data, and we are going to present our project, the NGO CEPAL. Our project is focused on the IDT. This Institute of Treatment and Diagnosis here in NGO CEPAL. So yeah, let's start. Andy, can you? Yeah, first, well, I wanted to introduce you our team. We have Lauren Osorio, who is our data architect, Diana Quiroga, who is our data technical leader, Andy Villanueva.
Just checking if it's my internet issue, because I couldn't hear anything.
Solo, we can't hear you.
Okay, yeah, I think now it's good. I think I still can't hear anything. Are you speaking, Gonzalo?
Yeah.
Yes, I think that Gonzalo have problems. Let's see. Give a minute, please.
Yeah, sure. Yeah.
Yeah. Okay. I think that I can hear you now. You can hear me now, Alicia, Karin? Yes.
Yeah, I can hear you.
Awesome. Yeah. Okay, we can continue. Sorry for that. Well, I wanna first talk to you about well, this institution, who is CEPAL. Well, CEPAL, well, the Hartford Centro para Aprendizaje y Lenguaje. It's the first institution in Peru to offer comprehensive care under clinical interdisciplinary approach for the prevention, diagnosis, and treatment in the areas of hearing, language, speech, voice, and learning in children, adolescents, and adults. So yeah, Andy, you can go next. As I was saying, our work is focused on the Institute of Diagnosis and Treatment. This institute has two primary jobs or works in two different areas. The first one is diagnosis, where they offer the evaluation service for all their patients that came to the NGO, and the second is treatment, where they offer the therapy service for all the results in the diagnosis area. So yeah, you can go next, Andy. I want to talk about a few numbers about the NGO. Well, first of all, we have 700 children per month that are cared for in the diagnosis area. Next, the institute was founded in 2017. So from 2017 to until 2021, that was our where work started. We have almost 20 tables of data, over 420 dating of the patient's history, and over 10,000 patients. So we ask the question, is there relevant, available, and integrated information to make decisions? And that was our primary focus on. So in order to answer that, we find some relevant information about what was happening on the NGO right now. So we found that they did a lot of manual collection of relevant information. All of the data they had are manually collected and manually stored. So yeah, that was the first one. The second one, we find an opportunity for improvement and measurement of the treatment effectiveness. In order to, the Institute aims to find better ways to treat their patients and better ways to bring their service to the people. So we find like an opportunity to measure their treatment effectiveness in order if they are like trying or accomplish their goals or not. The first one was timeliness of information consolidation. When they want to some information or some data, at the moment they actually spend a lot of time or more than they should in order to consolidate that information or to answer their data questions. So yeah, in order to that, we propose a dashboard. And that dashboard, in order to have three main points. The first one is integration, diagnostic and treatment information in only one place in order to communicate both areas. Dynamism and speed. How many appointments do we have in each of the areas? So basically, these two main areas work in appointments way. And the third one, understanding, because we want like a clear visualization in order to make quick decisions. How we achieve this? First we need the data. So we speak a lot we spoke with the NGO in order to find a connection to the data. So in order to do that, we connect to their database in SQL Server and use tools as Power BI in order to make the dashboard, but with previous data manipulation. We had to a lot of iterations, a lot of calculations, a lot of metrics in order to make our Power BI dashboard. And yeah, before that we use the tool. We can build our visualization as we want. And I don't know if you can. Yeah, there is. Well, and in order when we accomplish that, we find 4 project benefits. The first one was obtaining insights and relevant information in a quick and concise manner. That was some of the key findings related that we found. Next one, actionable information, because we want to make quick actions, as I said. Next, automated reporting. That is something that they spend a lot of time, so we can improve this. And the last one, more time dedicated to information analysis. That is something that they don't do too much, and they want to. So yeah, and this is, well, some numbers are after we made the solution, we made the dashboard, what they think, what was the situation later. So we find that, well, we reduced the time obtaining information from 60% of their time to only 10%. Time for processing also, well, kept in 30%. Time for analysis improved. So today they spend more time analyzing their data than obtaining the information. That was a very manually job that they used to do. So yeah, that is our improvements in time and effectiveness. So yeah, well, after that, our analytical dashboard, we propose 2 more solutions for the main problem of the NGO. I think that Renato is going to explain it about the topic modeling and probability treatment success.
Thank you, Gonzalo. Okay, team. Yes, we have 2 other proposals of project, and this is with the aim of trying to help the CEPAL team to try to analyze the data and also understand it, the variables that they have in the data. So we can say we have these 2 projects. Topic modeling is a well-known right now, is very famous NLP, but we wanted to make a good understanding of what about in the data of the reasons of the treatments. And we found out interesting groups of or clusters of topics that could represent the most of the reasons why the mothers bring their kids into CEPAL. And also the probability of treatment success. This is a kind of a simple model. We wanted to make it very simple, but we wanted to try how to understand which are the variables that can make a good improvement in the success of a treatment, because we have the data which we can say which patients or which patients were successful in their treatments and which were unsuccessful. But a lot of reasons we can say that the treatment wasn't finished by them. We don't know the reasons. Also other reasons that the payment and so on. So we can continue the presentation. Gonzalo, please. Yeah, the first one in the dashboard for CEPAL team, we have this word cloud. It was very interesting to see some words, for example, language. We can say it's very hard. We can say that there is a lot of correlation between emotions and also the words of CEPAL team, that is the treatments, I mean, language, pride, and so on. And also in the dashboard, we have this kind of endograms that is trying to, it's not working with unstructured data, it's working with unstructured data that we can say that, okay, this is it's by a person writes this kind of or select this kind of topic, but it's not in an unstructured way. You can say this is not a test and it's not a comment. So what we want was trying to visualize the reasons in clusters related to unstructured data. And this was using BERT topic. This is a well-known, we can say, state of art to understand or to see or to find out clusters in the text or in documents. So BERT topic uses, well, the methodology of the project in GitHub uses TF IDF to see the frequency. This is a formula that sees the frequency of a word in a document and also in a word across the documents. And also we used a cluster. I remember that it was PDF scan or something like that, that uses PCA to all the embeddings, all the vector in the embedding of BERT, trying to put in 2 dimensions, and we can see the clusters very in a visualized way. So using BERT topic, we put or we filled in with all the reasons of why the majority of the patients go to CEPAL team. And we found out, next, Gonzalo. Next view. We found out this, we can say 6 most important topics. We can see a little, or we can see any word, but we know that this is algorithms, we know that this is mathematics, and what we want to communicate to the CEPAL teams is, okay, we want to see the most important related to the we can say the business in business terms. So the next presentation, we can say this is the most in the next view, please. The next, yeah, we can say this is the most important clusters. This is the 4 most important topics. It was very good because we can see the association of school, psychological, emotional, is well that, okay, the kid that has this treatment, sorry for the noise, was in the most of the comments was like learning and emotional was together. It was like the kid was suffering something like in the school, and it was impacted emotionally to the kid. And also we have this reading, understanding, writing, and focus. The most of the comments is like the kid who has reading or writing problems also have this kind of focus, understanding of what he's doing with when he's trying to understand and to learn reading and writing, but he has problems, we know. And the next one is parents crying concern. No, sorry, before. Parents crying concern, frustration, and noise. It was a little interesting, this kind of clusters that we found out or we had as a result of the BERT topic. And this is the first topic modeling extra project, we can say. And right now we wanted to next. Yeah, here. I think okay, here we have trying to make this treatment success probability model. What we wanted to make was like using a statistical model or well, to make a prediction, trying to figure out which are the variables that we can say if we put a lot of effort in this variable or if this variable is high enough, we can say the probability of finishing the treatment in a successful way can increase. And so first we wanted to go to the data. We went to the data to, sorry there for the noise. We've defined the target that was like the successful treatments was like it was like all the treatments that had a date or finished date, and all the unsuccessful treatment has also a field that says why they didn't complete the treatment. And also we recollect all the possible variables from data. We have descriptive variables that is like this kid has these parents, he has brothers or sisters, he has insurance, he has, oh, well, his age is 18 and so on. And also we're trying to make feature engineering that is like the number of treatment days, the number of we can say how many visits were completed, because it can be programmed, but it can go or something like that, and other variables that we want to create. And so the second part was the model. Here we wanted to try to logistic regression model, but only for interpretability purposes. We know that if we go to Cepal's team and say, okay, this is a neural network, and we can explain very well, because if we don't know how it works, what I have to think that Cepal's team is gonna understand the model. So we have good, we can say good scorings. We didn't want to make the perfect model and that stuff, but we wanted to try to get the sample data to train this model, to have this kind of balance of who didn't complete the treatment or who completed the treatment. So we are trying this logistic regression model, and then we trying to understand the coefficients. We know that the logistic regression model works with the base or the independent variable. I mean the base coefficient, we can say the baseline coefficient, plus all the variables times their weights. So then this is like the linear model, but we wanted to put it in the probability of the logistic regression. So then we have this kind of probability that it could go with the successful treatment or the unsuccessful treatment. But what we want with this logistic regression model is uses, this is one for the class from MIT, the margin result. The margin result is very good, because it gives us information about if we, I don't know, increases this variable in 1 unit, we can say if the margin result of the variable is, I don't know, 8%, because margin results is in percentage points. If we increase this variable x1 in 1 unit, the probability of success or treatment success increases in 8%, for example. So we wanted to use that functionality. Next, Gonzalo. Next. So we build, we can say these building blocks, because we have this base. We can say if we did not improve any of these variables, I mean, number assurance is 0, treatment cost is very low, appointment effectiveness is 0 or something like that. Flag median time pass, I'm going to explain that the variable, and others is 0. We can say that the treatment success probability would be 75%. But if we increase, for example, number assurance in 1 unit, because in the data was like 1, 2, 3, 4, 5, so on, we can say that the treatment success probability increases in 3.5%. And the treatment cost also increases in units. Then I try to scale the data, because the treatment cost was it was a variable with a lot of units. And appointment effectiveness, this variable was like, this is a KPI, like number of we can say the total number of all we can say like the total appointments the number of payments that were completed or were visited divided by the total number of appointments. And it was this kind of, okay, if this person goes to all the appointment, because we saw that it was not very high enough, this KPI in all the population, it was very, to the model was more important. And also we created this flag median time pass. It's like a Boolean variable that what it says is like, if we calculated the median time pass, what was like that? It was like all the people who completed the treatments, what was like the median timing. And if this person it passes this median timing of all the treatments for people who completed, and it was like the half of the timing, and then the median of all the half of that timing, we can say that this is the flag. We can say this is one. If it's not yet the timing of all the treatment doesn't pass this threshold, we can say zero. But it was significant to the model, this kind of feature engineering. And others, it was very low, the margin result. We can say it was 0, 0, 0, but I can consider all in 3%. So this was trying to explain to the support team, this is our, like, for the moment, the most important variables, and also the data we can gather, we can, and it was allowable to us. So this is all the presentation of the support team. We wanted to make this 3 months as a success probability model because we wanted to make something very interesting, and also the clustering, because it was an initial purpose. We didn't get all the data, so we didn't finish the clustering, but we wanted to make another kind of project related to the topics we studied in the MIT classes. So it will be all. Thank you. Thank you, Gonzalo. Thank you.
Great. So thank you so much for the presentation. It was definitely very interesting. Like I think it's like a great combination between like stats and machine learning as well. Yeah, like I do have like a few comments to make sure I understand it correctly. So like so the meeting notes you mentioned, are they self-reported by the patients when they make like appointments, or they're more like generated by like maybe like a doctor or like a third party? Like the appointment notes.
Sorry, I didn't hear you very well.
I'm saying, like, I'm asking, like, if the meeting notes, are they self-reported by the patients, or like when they make the appointment?
Well, the appointment was programmed, well, the data we have in the system, so they make the appointments, but also is that we can say, if it's like a match between the patient timing and also the company timing, because they have a lot of appointments. So I don't know how it works, but the data we receive from the organization, and also the programs, and also the work completed.
Yeah, definitely. I also imagine, like, because I think you guys, like, I really like the topic, using BERT topic for the topic modeling part. And like I would imagine it would be like also interesting to maybe like, because I know there are like a lot of like words that are related to like either the moods of the patients, or like some like symptom of the patients. And like I imagine it would be like very interesting to do like also maybe like a sentiment analysis, or like some other like prediction task, just to like cluster like whether this based on the appointment, whether this is like some symptom that we should treat right away, or it's like more like maybe they're like oh very serious, but like I was thinking maybe like you can cluster like whether they're like you can predict like the how serious each like symptom will be.
Yeah, I think that, well, Renato can answer that, but a little comment is a lot of what are you saying, it's related to really sensitive information that it's really hard to access. I don't know if Renato wants to say something more.
Yeah, it was very interesting, but we didn't have the data because we wanted to try a sentiment analysis prediction, but it was reasons. Most of them were we can say done by the personal, the CEPAL personal. I mean, it was not the patient. So it was the patient or the kid's mother was telling to the personal or CEPAL personal, oh, this is my problem, and the personal was like typifying the, okay, this mother says that his kid was like, it was more like a typification of the situation of the problem. So the sentiment analysis was, I didn't know if it can be significant, but if the comments would be from the kids or the mother, it would be very beneficial, and it would be very interesting to see that sentiment analysis.
Yeah, definitely. Like I would also imagine if you have like repeated appointments, then like you might also analyze whether this like kind of like whether this treatment is effective, or like actually like people are actually happy with the results, because like they put like notes for like repeated like visiting. And like I'm also wondering like if like so is this like the number of topics, is it like determined by the model automatically, or you have to like maybe
the model gives us more topics, but
okay,
as you see in the graph, we can see the most important or significant are the bigger ones, or the bigger circles, and the little ones is like, okay, we can say this was a correlation in the mathematics of the model, but the big one we can say, okay, this is like significant, and we can go to the data, and we wanted to just make it simple, so we went with 6 clusters. So the 6 bigger clusters that have, we can say that they repeat in most of the comments of the data. We try to get those ones and just use it for this for all the we can say this presentation, also to the CEPAL team to communicate, okay, this is like the words and also the adjectives or another words that are more correlated, that are together almost all the time, and it would be very interesting if they make some kind of strategies.
yeah, definitely. Like yeah, I was thinking like because it's like a deep learning model, so like the cluster itself is like a little bit hard to like interpret like to start with. Yeah, definitely. Like there are like a lot of like they might just like be related to like the like one cluster contains all the verbs and like one cluster contains all the nouns or something. Yeah, definitely. But like this is like a really nice visualization too, I think.
Yeah, I mean, there's a lot of science there, and yeah.
So I think my second question is related to like the second part for like predicting the treatment success. I know because like I think you guys are went for like the more trying to be more like to make the results more interpretable. Like my question is like is it possible for like is it possible to have like maybe interactive terms in the regression? Like even if like you have like a linear regression, you could still like add like maybe multiply two features together. So like maybe like there are like some correlation between I would just guess like maybe treatment cost and age, or like treatment cost versus like insurance. Then like you might just like see like an interactive effects from this when you add that to the regression as well. I'm not sure if I'm not sure if it makes sense. Like so like maybe like you have you can like combine two features together and make them like one variable for the regression. Yeah, like maybe like something like treatment cost multiplied by the age or something, like the age of the patient. So like you will see like some interactive effects between the variables. So like it will still be like a linear model, but like you could like see like a more complex relationship. Yeah, but like in general, like maybe like just wondering like if you guys have like also research on like whether there are like correlations between different features.
That sounds good. I mean, it's very different, that kind of methodology with PCA, no? Because PCA trying to dimensionize two variables, we can say in one, and this variable has the information of both. But you think timing the two variables to get, I mean, it's like another multiple linear prediction, but it can work. I mean, it can work to see a good relationship.
And did you guys see like some variables are more like likely to be correlated with each other?
Yeah, I mean, we're a little, but we wanted to make this threshold of 80% correlation and get rid of them, because we found out, Pearson correlation.
Yeah, but I think it's like definitely like a good like I think logistic regression is like what most people would go for like in real life, because it's like
the simplest,
it's definitely like
it's the simplest code, but what we wanted is for interpretability purposes.
Yeah, definitely, yeah. I think it did get like used a lot in real life because it's like very easy to like interpret the results. I think that's like mostly my comments, like maybe like also a few more like self-reflection questions for you guys. Like if you have more time, what do you think you could have done better in this project?
Yeah, sure.
Like I mean, like if you have time, like what other directions would you explore?
Well, we wanted to have more data, but this was not allowed because we wanted, for example, get a little financial per client or per patient, but it was very private, that data. So we wanted to work with the data, the possible data we could gather. And also we wanted to go further in the feature engineering. I think we could have made a lot of, as you said, more interesting variables, like this variable times this variable, this KPI. And because as you saw, it was more simple variables, it were more descriptive variables. So we wanted to go further in the data. And also trying to make another model also, and with, we can say with more time, we could understand very well and we could communicate very, very well that model.
Definitely. And is there like any, have you encountered like some issues or like obstacles that you didn't expect before while doing this project?
Yeah, I mean, it was at the beginning of the project. It was they didn't give us the data faster. We have to wait a little, but we wanted to to work and to make more improvements in the model. So, I mean, was the first obstacle. I don't know if the team has another obstacle. Also, the timing, because everyone is working.
Can you hear me? Renato, can you hear me?
Yeah, we can hear you.
Alicia, Renato, hi. My name is Laren. I am part of the group of the team. With respect your question, so I would like to imagine. I would like to have more data regarding the treatment itself. For example, capture image or videos when the patient is in the full treatment. Imagine. Because it is known that the problems that we can find are related to the speech, listening. Imagine creating a device that helps them to get better at this. Imagine that we can recollect more data. We can use them to create a device that it will be used to improve the listening or maybe the speech. So I would like to work more about it, because I think it will be interesting. Try to use them and try to help the people in the treatment itself.
Yeah, definitely. I would imagine there will be like maybe a lot of like privacy issues, but like I think it's definitely like an interesting way. And like I'm thinking like, because I think there's like also the diagnosis procedure. Like I'm wondering like if it's like okay to collect maybe data from the diagnosis part. Maybe like you do like some test on like hearing or something like that.
Yeah.
That's really cool. Yeah, I think like data privacy is becoming like really like an issue for like a real issue for like both projects. Yeah.
Thank you.
Thank you. I think Karen, I think we're probably out of time if you want to say some concluding remarks.
Yeah, I just like to, I just want to say I'm really impressed with everyone's project, both, in the software terms and the data analysis itself. Of course, there's always, you didn't have 2 years to do everything, but I hope that, if you have time that you could continue and keep reflecting on what would make your project better. Yeah, so congratulations. These are really great projects, and I hope you're proud of yourself for making this impact for the NGO in your country. And Alicia, thank you for all your really, sharp comments. And
like I think I really learned a lot from the presentation myself.
Yeah. So thank you. We will see you probably in the completion ceremony. And I wish you guys all the best. Good job. Okay. Good night.
Thank you, Karin. Thank you, Alicia.
Thank you, Alicia.
Bye.
Thank you, Lucia.
Thank you, guys.
Nice.
Congratulations to
Thank you.
everyone.
Bye, Lucia.
Bye.